Kaydon has 40 years in advanced technology. As he was talking a moment ago, he's been involved in a lot of conceptual designs and reviews of different programs. And obviously, he has, over the last 40 years or so, known a lot of pioneers, a lot of people that are involved in the industry. So he was a senior engineer at Boeing in advanced vehicle design. He has working about 150 programs or so, written books, written papers. So Kaydon is one of those guys who've basically have seen it all. I hate to use that cliche, but it is very true. So Kaydon and I really love this stuff. He's really a man who loves helicopter technology. He is a man who prophesies this technology. So without further ado, we'll let Kaydon talk. Go ahead, Kaydon.
Thank you. I guess there's so many memorable opportunities that I've had in my career. One of the most interesting was being on the evaluation team and being asked to evaluate whether or not the V-22 program should be funded by our federal government. And it was a political firestorm at the time. So there was a lot of money invested in it, around $4 billion coming from the Boeing, Bell team. But it really goes back to some of the early days of some of the modeling that was done, stemming from the XV-15 and moving on to the Model 901 and 901X, the JVX program. So what happened was, let's see here, I got to go, do I just hit down, enter? Okay, so what happened was it ended up that with all the controversy that, I'm going to kind of go back and forth in time here, but there was a lot of controversy with Secretary of Defense Dick Cheney that he unequivocally did not see the value of the V-22 program from a cost perspective and also from an operational perspective. I would say probably the most notable facet of the V-22 was to replace the CH-46 tandem rotor helicopter, which was really noted for the VERT-REP mission, 25 nautical miles, and some OTH, over the horizon work that it did. So what happened is in 1990, Senator Daniel Inouye chaired a subcommittee that was going to look at the V-22 Osprey. And what happened with that particular committee was they then went to the Assistant Secretary of Defense, David Chu, the Honorable David Chu, and he looked at a bunch of FFRDCs, federally funded research and development centers. RAND Corporation is one. Most notable is the Institute for Defense Analyses. I was at the time supporting the Department of Defense directly and indirectly for SecDef, and I was an expert advisor to the Institute for Defense Analysis. And I was doing a lot of, at that time, believe it or not, we were actually looking at putting lift fans in the F-18, as we were looking forward and looking at an advanced counter-air fighter aircraft. But it ended up that a gentleman named Dr. Dean Simmons, a brilliant individual, was assigned the program leader. He brought Al Gesso in. I worked very closely with Al, and he brought me in, and then we actually had to compete to be a subcontractor company. And at the time, I had the company, I still have Praxis Technologies, but we actually won the award as a company. And anybody that went to the museum last night heard Dan Newman speak. Dan Newman was one of my early designers at Praxis. So we had the job of evaluating all the different aircraft, but first of all, we had to figure out what would be the competitive aircraft. So the key focus areas that were given to us by David Chu were, what's the overall cost effectiveness of alternative fleets measured over a 20-year period. That was the principal basis for the consideration. And then also, what was the near-term cost for alternative fleets? And then, of course, what would constitute the alternative fleets? So again, the path to the Osprey was very long. It was a circuitous path, very expensive. It was started in December of 1981, and it was a multi-mission, multi-role helicopter. vertical lift machine. It was part helicopter, part fixed wing. The Army actually had a big interest in it at the time, so it's very interesting to see where we are today with the V-280 Valor. That it makes sense from my perspective, going 40 years forward. Whether or not, that you're going to see that development. If you look at the development of the V-22, it's going to be very interesting to see what happens with the V-280 Valor. But what happened is the Army was in there. Of course, the Navy wanted to look at it for certain applications. In the Air Force, it was coming out of a Special Operations Command. It was an Air Force SOC mission. And that really stretched the capabilities of the mission. That was a 550 nautical mile mission. That was a radius of action mission initially. So you're talking an 1,100 nautical mile range capability with VFR reserves. That was a big stretch looking at trying to meet the shipboard requirements and the operational requirements for the Marine Corps and the Navy, as well as to try to meet these missions. But it ended up that in December of 1989, the DoD directed the Navy to terminate all V-22 contracts. So it came to an abrupt halt at that time, and Congress disagreed with that decision. So what was the approach? So we sat down, we being Dr. Simmons, myself, members coming out of the Pentagon, and we looked at this thing and we said, okay, well, one, we have a multi-role, multi-service capability. So that means we need a multidisciplinary team. We needed to identify alternative vehicles that were realistic for V-22 for implementation to the kind of IOC, initial operational capability timeframe, that we were looking at. We also needed to get the OEMs involved. And yeah, we knew they would be biased, but they were the developers of these different aircraft and the manufacturers. We also needed the military services and the operators. We needed to talk to the pilots. We needed to talk to the mission commanders. We needed to look at any battlefield capabilities that were out there and lessons learned. We needed to talk to the federal agencies, how they were going to perceive supporting this, and even organizations like NASA. And importantly, we needed to look at emerging threat identification and evaluation. That was not as simple as we thought initially, because you're going into, the Marines go into hostile territory. You're looking at operations which could be, even though we were looking for Navy to design, if we have some engine designers here, aircraft designers, you would set a power requirement for an atmospheric condition at 3,000 feet, 91.5 degrees Fahrenheit. The Army used 4,000 feet, 95 degrees Fahrenheit. But there were special missions that would look at 6, 7, 8,000 feet where the air is thin. So when you look at an OEI, a one engine and operative kind of design capability, it becomes very important to understand what environment you're going to actually be able to operate in. So the power plant became an integral part of the design of the aircraft, and we didn't even know what aircraft it was going to be. The other thing is we looked at a lot of the missile technology, and the portable missile technology, portable threats, air-to-air threats. And to do that, we had to reach out to the Air Force and to some of the programs that they had coming out of Wright-Patterson. Any of you that might have done air-to-air combat, there was a program called ASPEN, the air-to-air systems performance evaluation model, because we needed to understand what was going to be the air threat, what was going to be the ground threat, the ship threat. That became a very challenging analysis. So what were the criteria? What were the probabilities of success? What did it have to meet? From the congressional side, right, or from SecDef's side, it was affordability. You had to have an affordable aircraft. The taxpayers needed to be justified, needed to have justification as to why we're going to embark on this particular program, which seemed to be a $30 billion program at the time. We absolutely needed to understand the performance Vehicle design and performance, we needed to understand the safety, the crashworthiness, because some of the aircraft we were looking at were designed many, many years ago, like the CH-46, and they didn't have a level of crashworthiness built into it. Manufacturing, how is a new aircraft like the V-22 going to be manufactured? What was it going to entail? What were going to be the limitations of manufacturing? How many different vendors would be provided in the event that, particularly your vendors in what's called your SRAs or your WRAs or your subunit levels, your components? What if a company went out of business? How does that affect things? So we really got down to the nitty gritty. Mission capability. What did it have to do? What was the most important mission? How many troops did it need to carry? How fast did it need to go? And what was the justification for that? MEP, Mike Hirschberg mentioned avionics, right? Aviation and electronics, great term. But MEP is the mission equipment package. That is the complete suite of avionics and sensors that would be on the aircraft. What was that package going to consist of? What were going to be the multi-roles done by each individual service? So we had multiple services looking at the vehicle, but we also had within the service, what was the utilization? Because if each service could have more than one role, multiple roles, that would kind of justify, spreading the cost of the operations and being more effectiveness. Readiness, that was a big thing. We had to take a look at what was the current threat, what was the emerging threat, and when was the emerging threat? When would this aircraft go IOC, and what would the threat be? Let's say mid-90s, late 90s, maybe even year 2000, turn of the century. What kind of threat were we looking at? And would the aircraft be ready? And how many would be ready? And could it be fielded in numbers that it could be effective against maybe a division-level threat? Surveillance, looked at that. Survivability, we talked about. So one of the things that we were really privileged, and it was just being at the right place at the right time for myself and others that got to work the program, we got to work very, very closely with the OEMs, both NATO and US. And again, at this particular time, we were just doing basically a sweep of everything that we could understand that's out there to try to determine what aircraft were we going to really kind of, look and isolate. And then on the survivability, there was a newly formed center coming out called Serviac. It was the Survivability and Vulnerability Analysis Center. And we know that we had to work with them because, again, the threat analysis was going to be critical. So it ended up that after, we did the sweep, we came up with these alternative air vehicles, and we needed to understand the specific roles. Every one of the aircraft that you see there were real aircraft, except on the lower left, I'm going to call it the Boeing Model 360, but we're really looking at a new aircraft design. The Model 360 was actually built. It was an all-composite honeycomb structure aircraft. It was a fabulous designed aircraft, but again, it was a single prototype that was engineered by then Vice President Ken Grinham. Boeing did a great job with it. But so we looked at that, and then we also looked at the Super Puma, that was Aerospace at the time, on their Mark II. And then you'll see in the lower right there, the CH-60. I don't see my buddy Hippie in the office. He was a Seahawk pilot, but why not a Seahawk, right, which is the Navy version of the Black Hawk? We actually had to do that analysis and take a look at, would it be more effective to take a Seahawk and convert it into the Marine Corps role, or do we take a Black Hawk and marinize it? And it ended up that was an independent study that we had to do, and we determined that we would look at a Black Hawk and marinize it. So you take a look at the particular aircraft. We did not look at the 53 Delta. That's the twin engine model. The Echo is the 3-engine model. There's a reason for that, and we're going to kind of get into why we needed to look at the 53. And as you can see there, that's a 1 to 200 scale. kind of line drawing to just give you an idea of the physical size compared to the MV-22. Of course, the largest aircraft being the 53 Echo. So what we did was we had to analytically develop models for the performance of every one of these aircraft. And we got a tremendous amount of support from the various OEMs. And we did, I just had a short conversation with Nick Lapos that's going to speak later. But we did look at some of the technologies at the time. Sikorsky was flying the ABC, advancing blade concept, right, Nick? Thumbs up. And we looked at, some of the agility capabilities of the aircraft. The Army at the time had now dropped out, but they were looking at mask and lateral displacement. So everybody had these different, concepts of what the aircraft can do, thinking I've got these big T-55 engines, very heavy, with the rotors sitting out on the wing. Would it have the kind of agility and maneuverability necessary once it was at shore? We knew it had the speed capability and it had the range for long distance over the horizon target acquisition and ship to shore. But we had to model all of the specifics of these particular aircraft. So we built analytical models, and it ended up that we then had to run them through a battery of missions. And those missions were the traditional CH-46 mission, and they were also missions that were postulated with what's called a MUSOC mission. That's a Marine Expeditionary Unit special operations capable, right? We also looked at threat levels, right? When we looked at this thing, it was going to be at a division level. So a division consists of about 3 brigades. In this particular analysis, we looked at the U.S. deployment of a division of about 25,000 troops and all the associated artillery and other hardware and equipment on ground that needed to go with that. We also looked at the threat being a division-size threat, comparable threat. So we looked at that as an apples-to-apples kind of comparison. So when we looked at this, let's start taking a look at the flyaway costs, which were, this is then dollars in 1990. So you could see the V-22 and why the concern from Dick Cheney on what the impact was going to be from a budget perspective, from a taxpayer's perspective, that you look at that and you can see that the average procurement cost of the V-22 was significantly higher than, let's say, a Chinook, a Marinized Chinook. The CH-53, much larger aircraft. But the CH-53 Echo, we couldn't take out of the loop because it could lift a howitzer, a 155 millimeter howitzer. I mean, we were looking at basically lifting a Humvee, and we're going to kind of get into that. But you can see the recurring flyaway costs of the V-22 and the average procurement costs are significantly greater than the alternatives. Now, that is looking from an apples to apples, just buying an aircraft one-to-one based on a 20-year life cycle cost analysis. That has nothing to do with the mission effectiveness of these aircraft. Right. So then what happened is we then had to take a look at the mission utilization. And that became very important. So what you'll see there on the top, the big piece of the pie, was the amphibious assault, roughly 50% amphibious assault, and almost 62% or so when you looked at hostage rescue. So, and that became very important. The hostage rescue is part of the forces forward deployed in peacetime. So again, we had to look at, the conflict at the time, not a war, but a conflict, a battle, if you will, and then we had to look at the effectiveness in peacetime operation. You'll see also a small sliver there was Presidential Squadron, right? That was HMX, whether or not we would use the V-22 from HMX. That was just a handful of aircraft, I think 20 or 30 aircraft. and that was abandoned. We weren't going to look at that. It ended up that the Marine Corps didn't feel that that was going to be an effective use of the V-22, and actually might not be as survivable given the way HMX flies the president and the vice president around. The Air Force Special Operations mission had about a 12% or so piece to it. That was complex, right? To do that, we had to invent how are we going to make this aircraft go further without strapping on massive external fuel tanks like we do on the CH-47, right, or the MH-47 Echo. So the aerodynamicists at Boeing came up with, wing tips on commercial aircraft. These had wing sails. These were 4 finger-like sails that were, I think, 12 feet extended out to increase the efficiency. Did a lot of wind tunnel testing on it, but the mission just couldn't really be done, and eventually was abandoned for that specific, at that time, special operations capable mission. Navy search and rescue, standard mission that they do. They do the search and rescue with the Seahawks. At that time, it was the SH-60 Alpha model. Now it's the Bravo model. And then maritime pre-positioned forces, right? And that was in the employment. That was a considerable chunk of the amount of aircraft allocation we were looking at. So we had to kind of figure out, okay, let's focus on the amphibious assault for sustained operations. And the sustained operations, the key piece there. So the critical mission being the amphibious assault mission, again, we looked at the division size support from the Navy carrier battle groups, the amphibious assault ships, and the assets that were protecting those amphibious forces. And it ended up that, again, we did a like-to-like comparison on the division size threat. So what we proposed was that the Marine forces would be landed, half of them by surface assault vehicles and landing crafts, LCACs, landing craft air cushions, and the other half by assault aircraft such as the V-22 or the alternative aircraft that we mentioned previously. Now, the heavy equipment, as I mentioned, the howitzer, right, the M198, the 155 millimeter, 16,000 pounds, well beyond the capability of a CH-47, well, not a 47, I'm sorry, of the MV-22. But in this particular analysis for the missions that we were looking at for amphibious assault, only the 53 Echo could do that. The Hummers, the Humvees at 5,200 pounds, that was interesting because those were sling carried on the 47. The Model 360 or new aircraft as such would be sling carried, but the Hummer couldn't really sling carry from the wind tunnel testing that was done, couldn't really sling the Hummer, we thought at the time. Particularly in slow speed flight, hover flight and hovering ground effect because of the particular downwash and rotor wash on that aircraft. So the Hummer would have to be cinched up or winched up to near the fuselage of the V-22. So recognizing that the directive from the SecDef was money, what we had to do was to take a look at, well, how much money was going to be allocated if the program was to go forward. That number was $24 billion and then $1990. And if we looked at what's the equal size fleet, so we kind of worked it backwards. We said, we know what the budget is, so how many aircraft can we buy and operate over a 20-year life cycle, given the fact that we're going to have this division size engagements and that we also had peacetime engagements that we had to operate. And by doing that, as you can see, we look at the fleet mix, and right now, the V-22 all of a sudden starts to look pretty good, right? The V-22, based on, we could buy and operate over a 20-year life cycle of roughly 350 aircraft. And then, we talked about the Marine Expeditionary Forces, the MEF missions, the MUSOC missions, about 100 aircraft on the V-22. So you start looking at that, and then you look at the new Hilo, right? That would have been the all-composite tandem rotor, similar to the Model 3.6 that we talked about. That looked very attractive. Now, this doesn't get into some of the, this particular chart doesn't get into some of the considerations of building up your manufacturing facilities, time to manufacture, parts, suppliers, training, a whole bunch of other issues. We had to, eat the elephant one bite at a time, so to speak, when we were doing the analysis. And, just to put it in modern day terms, if you're following the eVTOL world and you look at Joby and you look at these eVTOLs, a lot of it boils down to the manufacturing capability of the aircraft, right? That's why the car companies that have that capability of building, a lot of vehicles effectively and in a short period of time, that's why you kind of lean towards them as opposed to building new manufacturing facilities. So a new Hilo, we didn't really consider that at the time, so that wasn't included in the overall life cycle cost. But it still looked attractive. Marinizing, by the way, marinizing the 47 was the same analysis as marinizing a Black Hawk compared to starting with a Seahawk. So there was no naval equivalent of a 47, so it had to be marinized. Then when you get into the smaller capable aircraft, like the existing fleet size of the 46 requires the 53 in its fleet mix for amphibious assault. The CH-47 doesn't on the MEF missions. So again, now the Super Puma Mark II was the same situation as pretty much the CH-60. And then we also looked at the EH-101, which was just coming online, which was a fascinating aircraft, coming out. It was new, it was being flight tested. The cool part about the job was I got to fly in all the aircraft, got to even sit in the co-pilot seat and put my hands on the controls. Used to fly the flight simulators. So we were able to model pretty accurately a lot of these aircraft. But when you looked at the 20-year operational life cycle for the mission on the amphibious assault and some of the other, what I'm going to say, secondary missions, at an equal cost of $24 billion, the V-22 was most competitive. So then we did a near-term cost analysis. Keep in mind that what we're not really seeing here much is a lot of the Serviac data that we did. There's still elements of the study that are still classified. The survivability, the mission effectiveness, the threats, but you can kind of postulate where this study had to go. So one of the things that we had to do was we looked at this near-term cost and what would have been a nominal production on the V-22. So the idea was, could we play with the numbers, right? Could we slow production down, slow the rate of production down, build less aircraft, ramp up later, and how that would affect the fact that some of these aircraft are in production. Okay, so they already have the sunk manufacturing cost. They have the ability for a higher output in terms of manufacturing numbers over a shorter period of time. And then we had to take a look at when would the basic IOC capability be, or at least when they would start to roll off production that could be fielded in a unit. And when we started doing that, if you can take a look at I'm going to say the net present value, as we looked at the net present value analysis of the aircraft, you can see that the V-22 with the nominal production run that was designed initially, or I should say requested by the Marine Corps, it was expensive, right? More expensive than the 53s and the other combinations of aircraft. And in terms of delivering the aircraft, okay, 1996 made sense. It was comparative, but when you get into the new Hilo design, even ramping that up and going through military quals to get that 3 years later, that would have been aggressive, but that's where you see the difference of 3 years because we had to qual a new aircraft and build up manufacturing facilities. The fastest would have been a 47, marinized version of a 47, and that was roughly a cost that was, two-thirds that of what the nominal production of the V-22, and it would still be able to be roughly the same time frame. The extended year would be because it had to be marinized, but the production facilities were already in effect, and they were already moving towards an MH version for special ops. Now, when we slowed the production down by 2 years, same number of aircraft, but spread it out over 2 years, the costs dropped tremendously, almost in half. Now, the difference is you were able to do that, able to field it in the same year in 96, but in terms of outfitting the fleet, that was pushed 2 to 3 years out. So then you had to take a look at where that threat was going to be 2 to 3 years out. So it ended up being a kind of a mixing and matching game to see how we could position each one of the alternative aircraft in the best light so that we were unbiased in our opinions. 4 minutes. Yep. Okay. Following. Yes, sir. Roger. Okay. So a couple of the things that I thought were interesting here would be to actually do a couple of Q&As on the congressional questions. So Senator Arlen Specter was very, very vocal when it came to briefing the House Armed Services Committee. Very, very Specter. So General Pittman, the Marine Corps General, 4-star, gung-ho, V-22. Specter said, well, I would ask you whether you agree with General Pittman's conclusions that had we had the V-22, in fact, lives would have been saved in the Panama operation. And the response really was, we have no idea, right? We can't tell you if lives would have been saved in the Panamanian operation. But one of the things we were able to say was, based on our analysis, it was the most survivable aircraft out of all of the aircraft that we looked at. Senator Specter again, and I'm just, not that I'm picking on him, but these were questions that created a lot of controversy and a lot of discussion and heated discussion. Specter, let's get right to the core of the issue to General Gary, the Commandant's position. Okay, he said the V-22 substitute scheme is ridiculous. So what the Marine Corps was doing at the time was, can't think of any other word, but poo-pooing looking at other aircraft, right? Why are you looking at other aircraft? We're the Marines. We need the V-22. We're not going to look at any other aircraft. We need this aircraft regardless of the cost. Well, that's just not the way it works, okay? So Dr. Chu basically said that he supported the analysis. He said he was a technical individual. He spent a lot of time with us. He looked at the modeling techniques. He looked at the analysis, the processes. He went through everything with us, thousands and thousands of pages of results. And he concurred that the study made sense. It was a valid study. So when we looked at, the COEA, the cost and operational effectiveness analysis, it was the large Echoes and the 47M helicopters are 1.7 to 3.5 times more likely to be downed by enemy air defenses, okay, than the V-22. Again, survivability. Can't really talk about those air defenses, but the V-22 was a lot more survivable in the Surviac and survivability models that we ran. And nobody disagrees, according to Dr. Chu, with the specific calculations. The absolute numbers are classified. They still are. But the key thing here is the reaction time assumed for enemy small arms fire is right at the edge of the speed envelope of the V-22, such that, in fact, the enemy gunners and the ability for them to field the surface-to-air missile do not have much chance against the V-22. Summary. Okay, the Marine Corps mission, the greater survivability of the V-22 and the new aircraft, all composite, provide a modern advantage in the amphibious assault mission. The V-22 was clearly the most cost-effective solution for Marine Corps sustained operations. The second best aircraft was a new aircraft, was to build an all-new like helicopter but it had to be carefully done and had to be properly funded. The third best was a Marinized CH-47. There were problems with the landing gear and the way the aircraft was balanced. For example, tip over angle. It had to have a considerable amount of re-engineering changes. And the last was the fleet combination of the 60s for troops and 53s for equipment. The air vehicle simulations and design and performance models were realistic and representative. Working with all the OEMs, we actually compared the model data with actual flight test data from real aircraft, and it was very accurate. The OEMs and military services were very supportive in sharing operational flight data and experience. We got to talk to a lot of pilots, a lot of mission commanders, battlefield ops guys. Survivability models were measured against known real conflict historical mission data. The cost models were validated against existing programs and realistic cost. And the models were accepted by mostly all the entities. At the end of the day, it's very difficult to refute what we have done because the data was compared to historical data. So that's why history becomes important and lessons learned become important. And it paved the way for the future. The V-22 is expected to serve out to 2065. We've seen numbers. The revamp plan will ensure the platform relevance to the end of its service life. As they continue to go now in fielding the next generation, the NGAS program, came out of Marine Aviation Plans. And the lessons learned on the V-22 will hopefully be applicable to the V-280 Valor, which is the Army's future long-range assault aircraft program.